Hello everyone. So welcome back to my channel and let's start with today's LeetCode challenge, that is minimum add to make parenthesis valid. Okay, so what is the constraints that this parenthesis string is valid if and only if it is an empty string. It can be written as A and B should be a valid string also, and it can be written as this A with the like brackets. Okay, and we are given a parenthesis string S, and in one move we can insert a parenthesis at any position of the string. For example, S is this. Okay, so one is open bracket, then close, then all the close. So now we can insert an opening parenthesis to be at like the starting, okay, or in the middle of this, right? Or we can insert a closing bracket also at the end or any position. And now we have to return the minimum number of moves required to make S valid. Okay, so we have this examples, this open, then close and close. Okay, we can insert at this position first, or we can insert at like after the first bracket open parenthesis. So we will have one insertion, so we will return one minimum number of moves we are required, right? And so let's just start with the intuition part, move it to iPad. Okay, so we have this examples. Now how we can do, either we can insert it here, either we can insert one open here, so that will make one open, then again open, then close, and then close. So this is balanced because this is balanced and this will balance this, right? So how many moves are required? Only one move, because we are inserting one open parenthesis. Since in this example all are closed, right? All are closed, so how we'll do, we will either insert one here and again either one here and either one here, or we can do one all this and all open after that, sorry, all close after that, right? Or we can do, we have these three, right? So what we can do, either we can insert one here, right, one here, and then one here. Okay, so these are all balanced because this is balanced, this is balanced, and this is also balanced, right? Now how we can calculate what is the minimum number of moves that we require. So if you can see, this is basically we have to balance all the pairs, right? Similar question that we did earlier was to minimum number of swaps, but in this case we do not need to do swapping, we have to insert. Okay, because so if we have this example, okay, this one, this one, there the number of parentheses open and close are equal, but in this case since we are inserting, it could be or it could not be, right? So in this case what do, we just do swapping. Okay, so we will swap this with this, right? So it will be balanced. Okay, but here we cannot do this, so we will use the similar approach but not same exactly like earlier one. So how we'll do, we will, like, let's just take an example. We have this, okay, this one and this one, right? Now if you have this, what will you do, we will check whenever we encounter an open bracket, we will check if there is any closed bracket to pair with this, and like so that it can be balanced, right? So this close will balance this, but this is still open, right? So for this we will add one. Okay, so that means the number of that we have open brackets or closed brackets that are left to be paired. So approach is number of open closed brackets that are left to be paired. Okay, now we'll take another example to better understand it. Okay, we have this. Okay, so last time we did swapping, so it can be balanced, but here we cannot do, we can only do insertion. So how we can balance? For this balancing, what we do, we require a open bracket. Okay, so we can insert here for this only before it, so this will be balanced. Okay, now we will remove it. Now we have these two. Okay, so these two and these three. Now again we have to balance it, right? So for this we will add one open, this will balance, and we will remove it, so it is balanced, we do not need that part. Again we have this closed and all three open. Okay, in one move we can only insert one parenthesis, that is also one move, one parenthesis addition, right? So that's why I'm doing this step by step. First is this, second is this, now third we will balance this. Okay, so this is also removed, so this is third step. Now for fourth step, what we'll do, we only have three open, so now we will add either one here, one either here, either here, or either here, anywhere it will be equal. So we will add here, this part will balance out. Now for fifth part, what do we have, starting these one, because this is balanced, right? So now again we have to balance either one of them, so this will be balanced, we will remove it. Now what we do have, for the sixth part we only have one open, and for this we will add one closed, and this will be balanced, right? So now we have all the balanced, and number of operations that we did six, so six is our answer. Okay, so how we'll calculate this is basically how much unbalanced pair. If you check for this example, if we do same thing, okay, and here, now for this example, what will you get? If you see that these two are balanced, these two are balanced, we only need to balance these three, right? So I will just remove it, and from first step what I will do, this I have and these two I have, right? So first I need to balance this first, or we can do for second, anyone. So I will do this for this first thing, first closed, so this will be balanced, I will remove it. Okay, and now for the second step we have these two. Now for balancing, either we can insert here, either we can insert here. I will try to do insert here. Now this part is balanced, I will remove it. Now what is left, this one open, and I will add one closed, and this will be balanced. So number of steps are three, right? So if you can see this pattern, the number of the number of parentheses, number of parentheses, okay, so the number of parentheses that are left to be paired, right? This is not paired, this is not paired, this is not paired. Number of parentheses that are left to be paired, this is the answer, right? This is the answer, right? If you can see. Okay, so since we did same question, related question earlier, we know that we can use stack, but whenever we like get this question in an interview, we cannot directly approach that stack. We need to think of some solution with any data structure. So how will you think of? I will give a short glimpse for that. So mostly questions, whenever you need to balance out something, whenever you need to balance out something, you need to balance out. Okay, so in that thing you need to like first do some operation, and whenever you encounter anything you need to balance out. Okay, so that is the balancing out. Whenever you need to balance out, you try to use stack or queue. Okay, because stack provides last in first out, and this provide, sorry, stack provides first in first out, okay, and queue provides last in first out. So these two data structures you will require whenever you need to balance out, okay. Mostly stack is required, okay. So I think we are good on this approach. Let's just like write the pseudocode. So how will we use stack? I will give that small approach. So we have this and three close brackets here, right? So this 5 is here we have. So what we'll do? We will take a stack, okay. Whenever we encounter this close, so we know that there is no open bracket on the left side. So we will add it in the stack, okay. Again we have this closed, we don't have any open on the stack or top of it, so we will add it, right. Now we encounter an open. Open means uh, we don't have any close, we have to close bracket on the right side, so we cannot do any operation on this, right. So we just simply add it in our stack. Again for this we will add it in our stack, right. And again for this, you see, again we will add, right. So three open will be added and all two closed will also be added. So now for balancing out all of them, we need all like additions. So stack dot size is our answer, you see. Okay, now we'll take the one example of a balance question. Okay, so we have basically two closed, then open close, then open close, and then two open. Now we have stack like this, okay. So what will you do? You will come here. For first, this is closed, you will check in the stack if there is any open for it. No, we will simply insert it. Again we will come to this, okay, no open on the stack top, we will insert it. Again you will come to this open. So for open you don't need to do anything, you will just insert in stack, because whenever you encounter close you need to balance out with that open bracket. So we have this open. Now you come to close. Close will check if there is any open bracket on stack top. Yes, you will pop it and you will move to next, because this will be balanced. Again open, you will insert it. Again you come to this position, so this will check, yes it is balanced, you will remove it, right. So now stack does only contain these two, and you will move to this open. Whenever you encounter open you will simply insert it, similar to here, okay. Now your stack size is 4. If you see how you will balance out this, you will need to add 2 here, you will need to add 2 here, okay. This will be balanced, this will be balanced, this will be balanced, this will be balanced. So for 4 additions you require, and your stack size is also 4, so you got your answer, okay. So the time complexity, if you directly see, this is big of n, because you are just iterating over the string that you have, and space complexity is also big of n if all the like parentheses that you are adding all are unbalanced. So maximum time complexity will be big of n, space will be big of n. You can also further optimize this, okay. So you just pause this video and try to do that on your own. We will start the coding part and we will do it together in that. We have this uh, question, so let's just try to write the code. Okay, we have the string, so we will create a stack of character type as our store. Now we will go for each character in the stack in the string. Okay, now whenever we encounter an open bracket, what will you do? We'll just have to insert it in a stack, because it will be balanced whenever that close will come. Okay, now what will you do? You will check, because this is open. Now you will encounter close. So whenever close will come, you will check if stack size is greater than 0, stack should not be empty, and stack dot top is equals to open, because then only we can balance it out. So you will pop it from stack. Okay. Now, if this is not true, either stack size is 0 or stack dot top doesn't contain. So that means that now you have to insert that uh, closing bracket in this. So you will just simply insert. Okay. You cannot balance. So we'll add some comments. You cannot balance this closing parenthesis. So add it in the storage. Okay. And now balance this closing parenthesis, right? Now when we come out of this for loop, what you have a storage which have all the parentheses which are not balanced. So you will just simply return this size. Okay, so we'll just try to run it. Okay, it is working fine for all the example test cases. Let's just try to submit it. Yeah, it is working fine for all of them. So yeah, now we'll do that space optimization thing, right? So the last time that we did was also big of one space complexity. So similar we'll do. So if you like, if you check that what we have did, we have to make count of the open and close. Only two things are given. Okay. And whenever you encounter a close, you have to check for open in the stack. So you just need to maintain two variables, open bracket count and close bracket count. Okay. Since we are using similar approach here, we will use same. So what will we do? We will have this example, 3 close and then this one, done, 2 open. Okay, we have open bracket, we have close bracket. So let's start. So initially they will be 0, right? Now what will we do? We will start with this. This is closed, right? So closed will do this part. This is already 0. That means we cannot balance it, right? So we will do increase the close bracket count, I think. Yes. So we will increase the close bracket count. So close bracket count will contain the number of close brackets which are not balanced yet, right? So now we will come to this again closed. Still this is 0. So it cannot be paired. So we will increase the count here, right? Now we will come to this again, same thing, we will increase the count. Now we'll come to this. This is an open bracket, so we will increase the open bracket count. Now you come to closed. So close will check if there's any open. So to balance it, right? So we will decrease the count. It will balance this part. Now we come to here, right? This is open. So we will increase the open. And again, this is open. We will increase the open, because closed, whenever close will come, close will check for open. If there is any open, we will decrease the count of open to balance it. So this is the approach that we did same in this stack thing, right? Whenever we encounter a close, we check for the stack top and check if there is any open. Similar thing we are doing here. Whenever we encounter a close, we will check if there is any open. If there is any open, we will decrease the count. If not, then we will increase the close bracket count to get our answer. Now we have 2 for open bracket which are not paired and 3 close bracket. Okay, so the answer will be 2 plus 3, that is 5. And if you can see, you have to do same thing for these 3. You have to balance here 3. Similar for these 2, you have to balance here, right? So the answer is 5. Okay, so let's just move to writing the solution. Yeah, so we did stack thing. Now we'll do int open bracket count, initialize it to 0, and close bracket count and initialize it to 0, right? Now what will we do? Whenever we encounter an open, we just increase the open bracket count. Okay, now whenever we encounter close, so this means we encountered a close, but we have to check if we have any open bracket, that means we have this greater than 0. Yes, then we will decrease it count to pair it, else we will increase the count of close bracket, right? So yeah, now when we return, what is the number of open brackets that still we have and close bracket that are still not paired, right? So let's just try to submit it. Yes, we have solved this question. Thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notifications if you want to get these videos regularly. And yeah, we will be solving regularly all the lead code challenges that we solve. And I have created a curated playlist for lead code 75, and we'll be doing that together. So yeah,